Yo, 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 balancing chemical reactions. Tips and tricks for success. Here's an overview of the tips for balancing. The first thing you guys should do is always to look for the arrow in the equation. You guys will list all the elements in the order they appear under that arrow. Number two, you guys are going to record the number of atoms present for each element and list on both sides of the equation. Start at the very top and check to see if the number of atoms are equal on both sides. If the number of atoms are equal on both sides, move on to the next element. And then once you hit something that's not equal on both sides, you guys will always look for the smaller number and multiply a number to that smaller number to make it equal to the bigger number. Because again, our goal is to make both sides equal. Then you guys are going to place that number you multiplied by as the coefficient, meaning the big number in front. And then you guys are going to repeat step 3 until all the atoms of each element on both sides are equal. If you are like, whoa, Mr. Tran, what does that all mean? Well, we're going to try some examples and you guys are going to see step by step on how to do this process, y'all. So let's go. So we want to balance the following equation. We have aluminum plus sulfur yields aluminum sulfide. So let's look at a molecular model of this. We have these circles here. I have aluminum. There's no subscript, so we know it's 1. So I see a silver circle. For sulfur, I see a yellow circle. And then aluminum sulfide, again, there are these subscripts here. So aluminum should have 2, and we do have 2. And then sulfur has 3, and we see 3. But since it's one molecule, it is all connected. In order for the left side to be equal to the right side, we need to add circles on the left side. So aluminum's circles here are 2 on the product side. So I need another circle on the reactant side. And for sulfur, over here, a total of 3. So I need 2 more circles. So now, how do I represent that as numbers here? So a big 2 for the 2 aluminum and 3 for the 3 sulfur atoms there, and then a 1 because we don't need to add any more of the aluminum sulfide. So without using models, y'all, we can still balance the equation by using the tips for balancing from the previous slide. So let's have at it, y'all. I'm going to now balance using the technique on the previous slide. Okay, so we first list the element in the order they appear. So aluminum and sulfur underneath the arrow. Now I count out the number of atoms. So aluminum on the left side has 1, sulfur has 1, and I'm looking at the subscript, y'all. The subscript. Since there's no subscript, it's just 1. Now on the product side, aluminum has 2, sulfur has 3. So I always start at the top and then see if they are equal to each other. Aluminum obviously isn't equal, so I always go to the smaller side. And I ask myself, what number times 1 gets me 2? So that number you want to multiply by is your coefficient. So now I'm going to take 2 times 1 to get me 2. So now aluminum is equal. I move down to sulfur. I do the same thing. I ask myself, what number times 1 gets me 3? So the answer is 3, y'all. So 3 times 1 gets me 3. They are both equal. I am done balancing, but there's an empty space here. And again, if there is a blank, it just simply means there's a 1. So the numbers match on either side. We are considered balanced. Okay, let's balance the following. Lithium plus oxygen yields lithium oxide. So again, I'm going to use the balancing tips. I locate my arrow and I list the elements underneath the arrow. Then I count the number of atoms on either side. I'll start off with the reactants. Lithium has 1, oxygen has 2. And again, I'm getting my numbers from the subscript here. If there's no subscript, it simply means 1. So lithium on the right side, the product side, has 2. Oxygen has 1. So now I go back to the top and I balance, y'all. So 1 and 2, I go to the smaller side, y'all, and ask the question, what number times 1 gets me 2? So that would be 2. So I put a 2 over there. And when I do, I multiply the subscript by 1 and I get 2. So now lithium is balanced. Now I go over onto oxygen. The smaller side is 1. So I ask that question, what number times 1 gets me the bigger number, which is 2? So the answer here is 2. So I simply multiply the subscript by 2 and I get 2. But I did not only change oxygen, I also change lithium. So 2 times 2 gets me 4. So now I'll go back to the top because now lithium isn't equal. So I'm going to erase that number and I'm going to ask myself that question, y'all. 2 is no longer valid. So what number times 1 gets me 4? So the answer is 4. So again, I times 4 with 1 and I get 4. So now it is balanced. Any empty space, y'all, I'm simply going to put a 1 and there's my answer. We're going to balance iron plus water yields hydrogen and iron 3 oxide. First things first, we need to look for the arrow. We found it, so we're going to list out the elements underneath that arrow. Fe, H, and O. Now we're going to count the atoms. And again, this is just looking at the subscript, y'all. Again, just look at the subscript. So 1, 2, and 1. Now on the other side, Fe has 2, and I found it by looking here. H has 2, O has 3. So now we start at the very top, and we ask ourselves, looking at the smaller number, what number times 1 gets me this number here, 2? The answer is 2, y'all. So 2 times 1 gets me 2. We are good to go. That's balanced. Now H. Both of them are 2. We move on to O. So the smaller side is this 1 here. What number times 1 gets me 3? So the answer is 3. We multiply it by 3, but we also multiply the H as well. So 3 times 2 gets me 6. So now I go back up to here and go to the small side. What number times 2 gets me 6? The answer is 3. So I change that number to 6 right here. Okay, so they're all balanced now. So now I look for any empty space and put a 1. Okay, that's it for this problem. So balance the following. Iron plus bromine yields iron 3 bromide. So again, we go list the elements underneath the arrow. So Fe, Br. So now we go back and count the subscript. Okay, so Fe is 1, Br is 2. Then we have the other side. Fe is 1, Br is 3. So now we start at the top. Both Fe are equal, so we go to the bottom. So we have 2 and 3. The smaller number is 2, so I'm going to work with a smaller number. So now I have to ask myself this question, y'all. What number times 2 gets me 3? Whoa, 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 that doesn't work. So now I have to think of a common number that would be equal to each other. So 2 times 3 will get me that common number. So 2 times 3 gets me 6. We want both sides to be equal to 6. So what number times 2 gets me 6? The answer is 3. So I change my number, I get that. Now I go on to the product side. What number times 3 gets me 6? And that's 2. So this changes to a 6, but I distribute the 2 to both FE and BR, so FE changes. 2 times 1 gets me 2. So I go back up to the iron and go to the smaller side and ask what number times 1 gets me 2. So the answer here is 2. So now both sides are equal. I am done. It is balanced. Time to balance the following. We have iron 3 sulfate plus sodium phosphate yields iron 3 phosphate and sodium sulfate. So I see the SO4 and PO4. Those are called polyatomic ions. They act as one unit. Okay, so I'm going to find my arrow, identified, and now listing the elements underneath it. So I have Fe. Then I see SO4, y'all. I'm going to put SO4, and here's a tip that you guys should write down. Do not separate polyatomic ions. So again, SO4 and PO4, those are polyatomic ions. They were located on your page from last semester. So Na, and then PO4 is another polyatomic ion, and I shouldn't separate them. Now, counting the elements. So we have Fe, I see a subscript of 2. SO4 has a subscript of 3. And I'm looking at this right here, the 3. So I put a 3. Na has 3. PO4 has no subscript. Again, I don't count that 4, y'all. It is part of my element. Again, polyatomic. You keep them together. So I'm looking on the outside of it, and there's no number, so it's a 1. Now on the other side, Fe is a 1. SO4 is a 1. Na is a 2. PO4 is a 1. Starting at the very top, I start on the smaller side. Ask myself the question, what number times 1 gets me the other side, which is 2. So the answer is 2, y'all. Multiply, they are 2 now. But I did not only change Fe, I also changed PO4. So PO4 turns to 2. Now going down to SO4, the smaller side is here. So what number times 1 gets me 3? I put a 3. So the 3 changes the 1 to 3, and also the sodium. So 3 times 2 gets me 6. Now moving down, y'all, I have 3 over here, which is a smaller number. What number times 3 gets me 6? The answer is 2. So again, the 2 multiplied to 3 gets me 6, but it also distributes to the PO4. So 2 times 1 gets me 2. Every single element and polyatomic ion are equal. And so I look for an empty space, put a 1, and I am done. Advanced tips for balancing. So this is just an overview, y'all. Treat polyatomic ions as a group and balance them as such. Balance one compound at a time. Rewrite the number of atoms as you go. Only add coefficients, never change subscripts. If H and O appear in more than one place, attempt to balance them last. And here are some tips there. If you see OH minus on one side and H2O on the other, rewrite H2O as HOH. So let's balance the following. Tin 4 nitrite plus potassium phosphate yields potassium nitrite and tin 4 phosphate. So I find my arrow and list my elements, y'all. So it's Sn, NO2 is a polyatomic, so I keep it together. K and PO4 is a polyatomic, so I keep it together. Look at the subscript. Sn is 1 on the reactant side. We have NO2, there's a subscript of a 4. So we write down 4. For K, I see a subscript of 3, so I write 3. PO4 has no subscripts, so again, it's a 1. Now on the product side, SN has a subscript of 3, NO2 has 1, K is 1, and PO4 is 4. Now starting at the very top, I look for the smaller side, and that is this side here. So what number times 1 gets me my bigger number 3? The answer is 3, so I put it as the coefficient, changing SN as well as NO2. So 3 times 4 gets me 12. Now I go to the smaller side, and that's the product side. NO2, what number times 1 gets me 12? The answer is 12. So again, crossing that out. And it not only affects my NO2, but also my K. So 12 times 1 is 12. Moving on to the next line. 3 is my smaller number. What number times 3 gets me 12? The answer is 4. So I put the 4 as a coefficient, cross that out, and now it's a 12. Now I move on. Not only is it K, but also PO4. So 4 times 1 gets me 4. Everything is balanced. So I look for an empty space, and I put a 1 for each of those empty spaces. I am done with balancing for this equation. We're going to balance the following. Barium plus water yields barium hydroxide plus hydrogen gas. So notice that I have hydroxide polyatomic on one side and water on the other. So I'm going to change water into HOH so that my OH polyatomic ion can be seen on both sides of the equation. So now I look at my arrow and list the elements, Ba, H, and OH. Now counting my atoms, Ba is 1, H, y'all, is on the outside here. There's only one H, so 1. And then OH, I have no subscript, so it's a 1. On the other hand, I have Ba as 1, OH has a 2, so I'm going to put 2 for OH, and then hydrogen gas has a 2. So now we balance. I have barium as 1 on either side. That is good. Now I have H as 1 on one side, and the other is 2. So I go to the smaller side jaw. What number times 1 gets me 2? So that is a 2. So that affects both the H and the OH. I am balanced. Look for the empty space, y'all. They all get 1s. I am done. So time to balance this equation here. I have C2H4 plus O2 yields CO2 plus H2O. Listing my elements, y'all. C, H, O. Counting my atoms, 2, 4, and 2. Now on the other side, 1, and for hydrogen I have 2, but look y'all, oxygen has 2 places. So if there are 2 different molecules that have oxygen, don't forget to add them together when counting the total number of oxygen atoms. So I have oxygen here, it is 2 plus 1, and that gets me 3. So oxygen is 3. Now I'm going to balance, y'all. Smaller side, what number times 1 gets me 2? That would be a 2. So that changes the carbon to 2, as well as my oxygen. So 2 times 2 gets me 4. So where does that happen, y'all? Right here. 4 plus the 1 oxygen on water gets me 5. So now moving down, I have hydrogen. 2 is a smaller number, so I go there. What number times 2 gets me 4? The answer is 2. So 2 times 2 is 4, but 2 times 1 gets me 2. So there I have it, y'all. 4 plus 2 gets me 6. Now I go to the last line. What number times 2 gets me 6? And the answer there is 3. So look for my empty space. It gets a 1. I am done with balancing this equation. That's it for today, y'all. Have a good one.